Welcome. On this lesson, we're going to talk about how can we solve functional equations. So on the first example here, we're going to use the substitution method, but let's understand what we've been asked. Here we have a function, which is defined as f of x plus 3 equals x squared plus 8x plus 16. This is saying that there's a function that if I plug in the expression x plus 3, this is my output. But what we want to do is we want to find out what would have happened if I would have just substituted x instead of x plus 3. So what will be my output if I were to plug in x instead of x plus 3 to this function called f? So how can we find out that result? So notice that everything just boils down to this. Is it possible for me to rewrite the expression x plus 3 as x? So how can we write down x plus 3 as just x? So this is the question that we want to answer right now. Well, notice that one way that we can do that is by looking at this x. And how about if we let this x right here? How about if we let this x as just represented as x minus 3? Because notice that if we do that, if we substitute the expression x plus 3, if we substitute the expression x plus 3 as x minus 3 plus 3, this is going to give us what we wanted, x. So one way that we can accomplish this is by looking at the expression of x plus 3, and we're just going to substitute this x value with the expression of x minus 3. So how does that look like? Well, we have this expression, and we said that we can accomplish that if we let this x as being represented as x minus 3 plus 3. Notice that that's going to give us what we wanted because the 3's are going to cancel out. So all we have done is that f of x is going to be equivalent to the expression of x plus 3, but every time we see an x, we're going to substitute it with the expression of x minus 3. So we're going to come back to this function right here. And I know that this is true. Every time we see an x, we substitute it with the expression of x minus 3. And now notice that we have an expression for f of x, because notice that f of x, the way that we have defined it here, it is the expression of x plus 3, but all we did, we substituted this x with x minus 3. And that's what we did. We substituted this x with this x minus 3. We substituted this x with x minus 3. We substituted this x with x minus 3. And that's how we got f of x. And at this point, it's just a matter of just simplifying. So let's simplify this. So this is just equivalent to just x squared minus 6x plus 9. And if we FOIL this, we're going to get 8x. If we FOIL this, that's minus 24 plus 16. So notice that all we're doing at this point is just simplifying. But here we have common like terms. We only have one x squared. So how about for those x's? We have an minus 6x plus 8x. That's 2x. So now we combine these like terms. We're going to have 25 minus 24. So that's 1. So notice that now we have properly defined a function of f of x. F of x is x squared plus 3x plus 1. And notice this expression, we can go the other way around. If this is f of x, then what is f of x plus 3? Well, that will be equivalent to x plus 3 squared plus 2x plus 3, which is 1. Which I'm not going to do the math, but I can guarantee that that's initially what we had here. X squared plus 8x plus 16. But this is what we wanted. We've been given the expression f of x plus 3, and we wanted to find out what f of x was. And all we did here, we took, okay, so we have information about x plus 3. So how can I make this x plus 3 into an x? Well, I can let this x be equivalent to do x minus 3. That way I get an x. So that's saying I'm going to the function, and every time I see an x, I'm going to substitute with x minus 3. And after doing some simplification, this is what we got. There's also another way to think about this, perhaps a more algebraic way. And another algebraic way that we can say is, say, look, I know that I want f of x, but let me just introduce this new variable. And I'm going to say this new variable is called z, and that's going to be equivalent to here, x plus 3. I'm just going to say that's z. And now perhaps if we're able to find out f of z, that will be equivalent of finding f of x. So notice that my equation is in terms of x, so let me just solve for x. So now we got that z minus 3, it's equivalent to x. And now what we can do at this point is we can come back to the function, so f of x plus 3, and we can just substitute every x with the term z minus 3. So we're going to have essentially z minus 3 plus 3 is equivalent to f of z, which we already said that is equivalent to f of x. It's just a different variable. So therefore, f of z is the same idea as just going to the equation, and every time we see an x, we're going to substitute with z minus 3. Oops, sorry. Z minus 3 squared plus 8, z minus 3 plus 16, and that will give us the same result that we got previously, which it was z squared plus 2z plus 1. Either way, we're going to get the same result, but just to keep it formal, we wanted to find out f of x, so therefore now we can say that f of x is equals to x squared. Oops, that looks like a z again. Let me just erase it. That's equivalent to just x squared plus 2x plus 1, which it's essentially the same result that we got previously. So now let's look at one more example here. Let me look at example 6. Let me just bring it down. There it is. So there's another method that we can use here, and that is what we call a system of equations. But now notice that this equation is stated a little bit differently. On example 5, we were given information about f of x plus 3, and we want to know about f of x. So this was just one equation where perhaps there was only one function that was unknown. But now if we take a look at example 6, notice that under example 6 we have two different equations, f of x and f of 1 plus x. So we cannot use the same method as we did previously. So this method pretty much just works out whenever we have an equation and we just want to rewrite it in a different format. That's what we just did. But now here, notice that we have two different equations, so perhaps we have to use a little bit more work than what we did previously. So one way that we can solve functional equations is by the method of a system of equations. But what do we mean by that? Well, notice that right now I have one equation, f of x equals f1 over x equals x squared. I have this equation. That's what's given. But now notice that if we let x be substituted by the expression 1 over x, so pretty much if we go back to the original function and every time we see an x, we substitute it with 1 over x, notice what we're going to have here. So now if I see an x, all I'm doing right now, I'm going to substitute with 1 over x. So I'm going to have 3f 1 over 1 over x, well that's just x, equals 1 over x squared. Now notice that right now initially I was given this function. But by doing this, by substituting this x with the expression 1 over x, I have a new equation. And let me just rewrite some stuff here. So I'm just going to align it. So 3f of x plus f of 1 over x, that's equivalent to just 1 over x squared. Notice that what I have done here, thanks to this substitution, I have written the same equation using the same functions, f of x and 1 over x on both of them. And now notice that I can just treat this as if it was a system of equations. You know, this is a very nice trick because all we have said is we have two equations, first equation, second equation, and two unknowns, f of x and f over 1 over x. So that's definitely solvable using system of equations. So let's just solve for f of x in this system of equations. So let me just rewrite it here. So now that I just rewrote it here, We want to solve for f of x. So let's see, how can we cancel out f of 1 over x? Well, notice that we can do that if we if we multiply both sides by -3. I have f of x plus 3f of 1 over x equals x squared. So now this becomes -9 f of x minus 3 f of 1 over x equals -3 x squared. But what happens now if I were to add those two values, or these two equations now? So if I were to add those two equations, notice that the expression 3f of 1 over x plus -3f of 1 over x, they're going to cancel out. So now what I end up having is just -8 f of x equals x squared plus -3 x squared. And let me just rewrite this as -8 f of x equals, what's that? X to the 4 minus 3 all over x squared. And by doing this, notice that we only have one unknown, and that's what we wanted. We wanted to solve for f of x. So if we wanted to solve for f of x, all we have to do at this point is just multiply by -1 over 8. So once that this is accomplished, this -1 over 8 is going to cancel out with this. And now notice that we have an expression for f of x. So now this becomes 3 minus to the 4th all over 8x squared. And now this equation, 3 minus x to the 4th, this looks like a 9, but it's supposed to be a 4. 3 minus x to the 4th all over 8x squared, it will satisfy this condition. And we're not going to check it, but you can trust your math skills. This equation here will satisfy this condition, so therefore this equation here is the solution of this functional equation. And we did a very slick trick in here. What we saw here is that this relationship between x and 1 over x, and that is that, we can kind of like write it as each other. And by doing that, we can let x be 1 over x. And by doing that, notice that now we have a system of equations with two unknowns, which again, right now the unknowns are the functions, meaning f of x, it's an unknown, f of 1 over x, it's an unknown. Notice that we have two unknowns with two equations, so we can definitely solve it using system of equations.